Hello students, welcome to Misostudy and welcome to my class. In my last lecture, I was discussing the question from organic chemistry. Today, I will continue with the same topic and will provide few more information. I know organic chemistry is not so much tough. If you have a command, solid command over the reaction mechanism, then you can easily solve such kind of questions. Now, given here, in my last lecture, I have told you solve this in your home. That is the chemical system that is non-aromatic. We know aromatic compound follow Huckel's rules. The first one is benzene. By looking at, you can say this is aromatic compound. Second one is naphthalene. Is it clear? It is also a what? That is aromatic compound. Third one is this one, azulene. This is also a aromatic compound by look at conjugate system and it follows for Huckel rule also. But the C option, look at, is non-aromatic compound. By looking at the figure, you can also observe that. So, but this is not a true things, don't estimate by looking at the figure. First follow Huckel rule, but here is the simple thing, so I can easily guess that C is the correct option. For question number 57, that is C is the correct option. Am I right? Yes sir, you are absolutely right. And I am going to rub this part and let's move to the next one. Wait for a moment. Sorry for the distance, there is a technical issue. Now let's move to the next one, question number 58. Yeah, that look at the thing. Among the following reaction, this is a more than one option correct. Among the following reaction, which give tertiary butyl benzene? What is given here? Which gives tertiary butyl benzene? This is the case, tertiary butyl benzene. Clear? Yes sir. Now this product, this very product is going to be formed. Now tell me how can you form this product, tertiary butyl benzene? Look at this thing. This is benzene, yes sir, and treated with this very much compound. This is Br and NaOC2H5. Clear? Yes. Now it can be written like this. Here is C, here is C, here is C, and also C. 4C and Br. It is also a bulky group and this is a bulky group. Due to this reason, when benzene is treated with this component and in presence of NaOC2H5, there is no substitution take place. Only elimination take place. Clear to you what I am telling? Due to the presence of, during my lecture I have discussed also, I have also discussed this thing, due to the presence of this bulky group, that is there is elimination take place, no substitution. So in this case, tertiary butyl benzene cannot be formed. Here look at, this is the double bonded compound. Here is carbon, this one is C, S3, CS3, and in this case put here that is CH2, like this in presence. Then in this case the substitution take place and the formation of tertiary butyl benzene possible. Similarly, here is also possible AlCl3. Look at AlCl4 plus and Cl minus, that is it can form the tertiary butyl benzene, yes. And similarly BF3, this is an important reaction. This is simple thing. I am not going to elaborate this thing. I am not going to waste your time and my time also. This is the simple thing. You have observed this in the reaction mechanism. So for this question you will say that is B, C and D are the correct option. Question number 58, that is B, C and D are the correct option. Wait for a moment. Now I am moving towards the next question. What is the next question here? Question number 59. This is an integer type question. The total number of stable conformers with non-zero dipole moment for the following compound. This question is one of the important question and the answer will be 3. 3 partially staggered form will have non-zero dipole moment, but you have to solve this question. This is very simple. In ethane you have gone through the topic, that is conformation, staggered, eclipsed, skew. So there are question that the total number of stable conformers total number of stable conformers with non-zero dipole moment, that is dipole moment is not zero. In this case, what, there are 3 partially staggered. For detailed solution, do it in your home. If you have any doubt, then I will solve this question again. Clear? So I am leaving this question for your homework. Now let's move to the next question. This is the question number 60. Question number 60 what? This is one option correct, and I have taken this question from the chapter solution, class 12, chapter number 2 solution. Solution is one of the most important chapter of physical chemistry. In this chapter, you have to clear out the things that is completely calculative type. First of all, in solution chapter, you have to find out how to find, you have to check strength of solution, molality, molarity, mole fraction, mass fraction, these are the things, normality, then ideal and non-ideal solution. What are ideal solution? Which obey Raoult's law, which does not obey Raoult's law, these are called non-ideal solution. If there is a non-ideal solution, we know there is a positive deviation from Raoult's law, or you can say positive deviation from ideal behavior, and the second one is negative deviation. Again I am repeating, positive and negative deviation. Ideal solution are those solution in which all the force, that is solute solute, so all the interaction force, that is solute solute, solvent solvent, solute solvent, are equal. Clear to you? Okay, and it follow Raoult's law. Now what third one is, you have to focus on Raoult's law. Raoult's law for volatile solute, that is Raoult's law for liquid, Raoult's law for liquid solution, and Raoult's law for non-volatile solute. Clear? That is solid liquid solution. Clear to you? Yes. There are 2 law, that is first one also we know, that is, tell me, PA is equal to P naught A into XA, and PB is equal to P. I am just giving you the general information related to this chapter. P naught B into XB. Clear to you? And PA plus PB is equal to P naught A chi A. This is a mole fraction of A, and P naught B, this is XB, this is the mole fraction of B. This is the case. PA plus PB is equal to P naught XA plus P naught B X chi B. Clear? And Raoult's law for non-volatile solute, lowering in vapor pressure, P naught minus PS upon P naught is equal to mole fraction of solute. This is the case. This is a general expression. Is it clear? What is the mole fraction of solute? Mole fraction can be written like this: mole fraction of solute is equal to Na upon Na plus Nb. Am I right? Now you have to practice the question based on Henry's law. Henry's law you know? Yes sir. Pa is equal to Kh into Xa. Kh is Henry's law constant. Henry's law constant. Okay sir. Then I'm moving here. Then you have to focus on azeotropic mixture. Yes sir, azeotropic mixture. It is of 2 types. Do you remember this? Yes. Minimum boiling azeotrope, minimum boiling azeotropes, and the second one is, that is the maximum boiling azeotropes. Again I am repeating, minimum boiling azeotrope and maximum boiling azeotrope. Am I right here? Yes sir, you are absolutely right. Then the next point, the next topic you have to focus, that is colligative properties. Colligative properties and Van't Hoff factor. We all know those properties which depends upon the quantity, not the quality. Clear? Now colligative property first is, this is also called as colligative properties of ideal solution. Am I right? Yes, colligative properties of ideal solution. Am I right here? Yes sir, you are absolutely right. Colligative properties of ideal solution. Now here the 2 or 3 things. There are 4 colligative properties, that is neither dissociation nor association take place. So this is the colligative property is valid for non-electrolyte system, or we can say diluted system, that ideal all dilute solution are generally treated as ideal solution. But if there is a electrolytic solution, that means to say there is a dissociation or association take place, then in this case what will happen, that is we will utilize to Van't Hoff factor to utilize the colligative properties for electrolytic system also, where there is a dissociation or association take place. We will discuss one by one. There are 4 colligative property we know. First one is relative lowering in VP, vapor pressure. Again I am repeating, relative lowering in vapor pressure. Second one is osmotic pressure. Third one is elevation in BP, boiling point. And the fourth one is depression in FPT, freezing point. Again I am repeating, relative lowering in vapor pressure, osmotic pressure, clear, elevation in BPT and depression in FPT. Clear to you? Relative lowering in vapor pressure, the formula is P naught minus PS upon P naught is equal to mole fraction of solute. Clear? Yes. Now osmotic pressure we all know pi is equal to CRT, or it can be written CST. Clear? The value of R or S is 0.0821 liter ATM per mole per Kelvin. Clear? Now elevation is boiling point, delta TB is equal to KB into M. What is M? That is molality. And depression in freezing point is equal to delta TF is equal to KF into M. What is KF? That is molar depression constant, and KB is equal to molar elevation constant. This is for non-electrolyte. If there is an electrolyte, then use Van't Hoff factor. In case of dissociation, again I am repeating, in case of dissociation the value of I is greater than 1. In case of association, the value of I is less than 1. Clear to you? Greater than 1, that means to say the experimental, or you can say actual molecular mass is less than the theoretical molecular mass. Clear to you? Yes. In case of association, that means to say the experimental and the actual molecular mass we are getting is more than the theoretical molecular mass. This is the case. Again I am repeating, in case of dissociation the experimental molecular mass is less than the theoretical molecular mass, and in case of association I is less than 1, the experimental molecular mass is greater than the theoretical molecular mass. Suppose if I write here MgCl2, it dissociate Mg2 plus Cl2 Cl minus. If I write here CS3COOH, it will form, we know, that is CS3COOH whole twice. Now here is association, here is dissociation. Look at dissociated, that is the experimental value decreases, but in association 2 forms 1. So in this case what we observe, that is the value increases. So this is the criteria, this is the Van't Hoff factor. So um, these are frequently asked topics. If there is a question from this chapter, if you have a command over this topic, then you can easily solve such kind of questions. So this is a brief idea of this chapter. Now let's move to the question section. What is given in the question? Wait for a moment, give me a few seconds. Yeah, now the things is, when 20 gram of naphthonic acid, okay, naphthonic acid formula C11H8O8. In this case, the given mass is 20 gram. The 20 gram of naphthonic acid dissolved in 50 gram of benzene. That is weight of solvent is, this is the weight of solute, and the weight of solvent is 50 gram, and this is benzene C6H6. Okay, the value of Ks, that is molar depression constant, the value of Kf is given 1.72 Kelvin kg per mole. Again I am repeating, 1.72 Kelvin kg per mole. A freezing point depression of 2 Kelvin is observed. That is delta Tf is equal to 2 Kelvin. The Ventov factor I is equal to, you have to find the value of I. Now how to solve this question? Yes sir. Now in this case we have the formula delta Tf is equal to I into Kf into m. This is a simple formula. Yes, delta Tf is equal to I into Kf into m. Yes sir. Now what is the value of delta Tf is equal to 2. What is the value of I? We do not know. What is the value of Kf? That is 1.72. What is the molality? That is number of moles of solute upon weight of solvent in gram multiplied by 1000. Am I right? Yes sir, you are absolutely right. Now what to do? That is 2 is equal to I multiply 1.72. Number of moles is equal to given mass upon molecular mass, weight of solvent in gram multiplied by 1000. That is 2 is equal to I multiply by 1.72. Then given mass, what is given mass here? Given mass is 20 gram. What is the molecular mass of naphthonic acid? That is 11 into 12 plus 8 into 1 multiplied by 2 into 16. That is 120 and plus 12, that is 132 plus 8 plus 32, that is 172. Am I right? Yes, 172. Clear? Yes, put the value 172. What is the weight of solvent? That is 50 multiplied by 1000. Am I right here? Yes sir, you are absolutely right. Now this 30 will cancel this 3. Now this 2 will cancel each other. Now what we have? We have 10 here. 172 cancel. Clear? Some more thing. W upon m 50. Yes. Then 5 to the 10. What we are getting here? That is the value of I is equal to 2. The value of I is equal to 2. For this question, we will say C is the correct option. This is a detailed solution, simple, completely theory based question. So if they ask such kind of question, then don't worry, put the formula. Yeah, definitely this is some calculative type, high calculation, time consuming, but still you can get the answer. Now I am going to rub this part and let's move to the next question. Now the next question is question number 61. Read the question carefully. What is given here? That is, the vapor pressure of a solvent decreased by 10 mm of Hg when a non-volatile solute was added to the solvent. Okay. Okay. That is vapor pressure of the solvent, that is delta P, okay, decreases by 10 mm of Hg, okay, when a non-volatile solute was added. The mole fraction of the solute in the solution is 0.2. Mole fraction of the solute in the solution is 0.2. What would be the mole fraction of the solvent? Okay, if the decrease in vapor pressure is 20 mm of Hg, in this case the decrease in vapor pressure is 20 mm of Hg, not 10 mm. Then how to find the mole fraction of solvent? So slight different. Do not go to the normal method. If the mole fraction of solute is 0.2, so mole fraction of solvent is equal to 1 minus 0.2, 0.8. This is not the answer. Look at here, they are asking when the vapor pressure decrement is 20 mm of Hg, then tell me the mole fraction of the solvent. Clear? Yes, sir. Now how to solve? We know that is P naught minus Ps upon P naught is equal to mole fraction of the solute. Yes, that is P naught minus Ps, that is delta P. Yes, delta P upon P naught is equal to mole fraction of the solute. Am I right? Yes. What is delta P according to the question 10? What is P naught? We do not know. What is P naught? What is the mole fraction of solute? That is 0.2. So what we are getting, that is P naught is equal to 10 by 0.2. This will move in upper circuit, that is 5, and we are getting P naught is equal to 50 mm of Hg, vapor pressure of pure solvent. Now let's moving here to solve the second part. It is given, now find out the vapor pressure of the solvent when delta P is 20 mm. Now the second part of the question. It is given again P naught minus Ps upon P naught is equal to mole fraction of the solute. That is delta P upon P naught is equal to mole fraction of the solute. What is delta P here? That is 20 mm. And what is P naught? We have got the value 50. That is mole fraction of the solute. This will cancel this one. We are getting, that is mole fraction of solute is equal to 2 by 5. Am I right, my friend? Yes, sir. You are absolutely right here. Yes, yes. I am definitely correct. Now, so what will be the value of mole fraction of the solvent? That will be equal to 1 minus 2 by 5. 5 minus 2 by 5, that is 3 by 5, that is 0.6. Again I am repeating, that is 0.6. Now moving here, check it out. For this question we are getting C is the correct option, 0.6, my friend. Am I right here? Yes, sir, you are absolutely right. Now I am going to rub this part and let's move to the next question. What is the next question? Check the thing. Yes, the next question is question number 62. Again this is a question from solution chapter. What will be the molecular weight of CaCl2 determined in its aqueous solution experimentally from the depression of freezing point? Okay. Now in this case, as we know, CaCl2 is an electrolyte. CaCl2 is an electrolyte. That is CaCl2 dissociate like this, Ca2 plus and 2Cl minus. Clear? If there is a complete dissociation take place, then the value of I is equal to 2. It means to say, it shows that I is greater than 1. Now they are asking what will be the molecular weight of CaCl2 determined in aqueous solution experimentally. As I told you during my lecture, that is what is given here, that is we know if I is greater than 1, then experimental or actual molecular mass is less than the theoretical molecular mass. Again I am repeating what I am telling, the experimental or actual molecular mass is less than the theoretical molecular mass. Clear? What is the theoretical molecular mass? That is 40 plus 2 into 35.5, that is 111. So what we are getting from the general formula, that is the experimental molecular mass always less than 111 in case of CaCl2, because there is a dissociation take place. If there is a association take place, then experimental molecular mass will be greater than the theoretical molecular mass. This is a general concept. So what is the answer? What will be the molecular weight of CaCl2 determined in aqueous solution experimentally from depression of freezing point is less than 111. Clear? Yes sir. Now I am going to rub this part and let's move to the next question, that is the question number 63. This is a question, simple question, theory question I have taken from the topic that is solid state. Now it's your turn, you have to solve. Tell me, solid state, it is one of the most important topic of what? Physical chemistry. In solid state you have to focus. I will discuss each and everything. That is type of crystal system. There are 7 crystal system. Bravious lattice. Clear? Yes. Then unit cell, simple cubic, face centered, body centered, end center, edge center, number of atom per unit cell, then packing fraction, packing efficiency, packing fraction in packing efficiency. They generally ask the question, what are the empty space, what are the complete occupied space, then void system, then and hexagonal close packing. Then you have to focus on the defects in a crystal. These are the important topics. Bragg equation also. Now read the question. This is a simple one. Simple cubic and face centered. Given here simple cubic and face centered. Tell me, read. Have these cell parameter A is equal to B is equal to C and alpha is equal to beta is equal to gamma, because this is a cubic. Cubic had 4 type, that is simple, simple, face center, body center, end center and edge center. Generally we study simple, cubic, face center and body center. So P is the correct option. Are 2 crystal system? No, there are single crystal system. Have only 2 crystallographic angle 90 degree? No, here 3. So and then belong to the same crystal system? Yes, simple, cubic, cubic. So for this P and S are the correct option. Again I am repeating, for this P and S are the correct option. Now cubic and rhombohedral, tell me, cubic and rhombohedral, different crystal system? Yes, are 2 different crystal systems. Simple answer. This is not a for cubic A is equal to B is equal to C, alpha is equal to beta, but for rhombohedral this is not a parameter, you know. Okay, have only 2 crystallographic angle 90 degree? No, cubic has 3. So this is not a correct. Belong to the same crystal system? No, cubic and rhombohedral are different crystal system. So only Q is the correct option. Cubic and tetragonal, again for cubic all angle are 90 degree also, but tetragonal all angle are not, all sides are not same, and this is not the parameter. And have only 2 crystallographic? No, this is not. PR belong to same crystal system? No, that is cubic and tetragonal are 2 crystal system, that is Q is the correct option. Now hexagonal and monoclinic, now tell me, belong to the same crystal system? No. Now have this cell parameter A is equal to B is equal to C? Tell me, A is equal to B is equal to C? No. Then are 2 crystal system? Yes. Have only 2 crystallographic angle 90 degree? Yes, that is Q and R are the correct order. This is a simple one. Bravious lattice, you have studied this thing. Yes sir. So for this question P, S, Q, Q and QR are the correct options. Yes sir, definitely. So again I am repeating, if you have a solid command over the theory, you can solve such kind of questions very easily. Now let's move to the next question. Wait for a moment. This is a question, integer type. Silver atom has a density 10.5 gram per centimeter cube. The number of silver atom on a surface area of 10 to the power minus 12 meter square can be expressed in scientific notation as y into 10 to the power x. You have to find the value of x. Okay. Now, how to approach? We know first of all silver atom crystallize as FCC lattice, face centered cubic lattice. Yes sir, face centered cubic lattice. Okay. Now, number of atoms per unit cell. Okay, number of atoms per unit cell in FCC lattice, that is equal to 4. Clear to you? Yes. Now, what is the formula of density? Density is equal to Z into A, atomic mass, upon N naught into A cube. Clear? Yes. Now, it is given the number of silver atom on a surface area of 10 to the power minus 12 meter square. So, first of all, we have to find the value of A from this data. Then, we have to find the value of surface area. Surface area will be equal to A square. Yes sir. Am I right? Yes, definitely you are right. Now put the value. Density is 10.5. What is the value of Z is equal to 4, and what is the value atomic weight, that is 108 upon 6.022 into 10 to the power 23 multiply by A cube. Now how to solve? That is 10.5 multiply by 6.022 into 10 to the power 23, okay, into A cube is equal to 4 multiply 108. Again I am repeating, 10.5 multiply by 6.022 into 10 to the power 23 multiply by A cube equal to 4 into 108. Clear? Yes. Now how to find the value of A cube? That is equal to 4 into 4 multiply 108 divided by, look at check, yeah, that is 10.5 into 6.022 into 10 to the power 23. Then A is equal to cube root, again I am repeating, cube root 4 into 108 upon 10.5 into 6.022 into 10 to the power 23. After solving, you will get the figure around 4 into 10 to the power minus 10. Clear? That is centimeter. Now, what is the surface area? That is 4 into 10 to the power minus 10 square, that will be equal to 16 into 10 to the power minus 20. We will put here 1.6 into 10 to the power minus 19 centimeter square. This is the surface area. Okay. Now, how to solve? This is simple. 1.6 into 10 to the power minus 19 centimeter square area covered by 1 unit cell. Then 1 centimeter square area will be covered by 1 upon 1.6 into 10 to the power minus 19 unit cell. Am I right? Yes sir. Now we have 10 to the power minus 12 meter square. 10 to the power minus 12 meter square. So we have to first of all convert meter into centimeter. We know 1 meter is equal to 100 centimeter. Am I right? Yes sir. So put here 10 to the power minus 12 into 10 to the power 2 into 10 to the power 2 centimeter square area will be covered by, that is 10 to the power 2 to 4 minus 8, okay, multiply by 1 divided by 1.6 into 10 to the power minus 19 unit cell. This is the unit cell, but they are asking you have to find the number of atoms. Number of atoms. Clear to you? So now we know this is the face center and they are asking about the surface area, not the volume. In case of volume, there is the value of Z is equal to, my friend, 4. Am I right? Yes sir, you are absolutely right. Now tell me how much area covered by the particle. This is the first, so Z is equal to here 1 by 4. This is the second again, plus 1 by 4. Then this one is completely that 1 plus this one again 1 by 4, this one again 1 by 4. So in case of surface, that is, what is the value of Z is equal to 2, not 4. This is the important thing, my friend. So number of atom will be equal to Z multiply unit cell, 10 to the power minus 8 multiplied by 1 divided by 1.6 into 10 to the power minus 19. What is the value of Z is equal to 2, 10 to the power minus 8 multiplied by 1 divided by 1.6 into 10 to the power 19. So after solving, you will get the number of unit cell. It's very simple. You can easily solve this question. Yes sir. So clear? This is a lengthy question, but this is JEE Advanced examination. So this is the important point. Don't put Z is equal to 4. Put Z is equal to 2 because this is a surface. Am I right? Check the calculation. You will get the answer. So my friend, now I am not going to introduce more questions because time has come. Now time has come to say bye bye. Thank you so much. In my next lecture, I will discuss few more questions. Till then, bye bye.